So during the operational life of the compressor, we will definitely come across some conditions that may not be favorable to the operations of the compressor. So in this section, we are going to look at some of these fault conditions and their remedies. Okay, so here we are going to be looking at the centrifugal compressors. Some of what we are going to discuss now is also applicable to other types of compressors. Okay, the axial and the reciprocating compressor, especially the piston type. So what are some of the problems or common problems that are associated with compressor operation? One is surge. So we are going to see what surges are and how we can actually remedy the situation, because surge is a dangerous phenomenon during the operations of the compressor. Then stall, which is similar to surge though of a lesser effect compared to surge. So we are also going to look at that. Then the high discharge temperature is also a fault condition that affects the operations of the compressor. Then high vibration, we have sea leakage. Okay, so the sea leakage, all of these put together, they will reduce the efficiency of the compressor unit. Then bearing failures, which can lead to high vibration. Okay, and eventually any other damage or any other fault condition as you see on the list here. So we are also going to look at bearing failures, what causes them, and how we can actually guide against bearing failure. Then erosion, especially of the impeller, okay, of the centrifugal compressor. So how it will affect the efficiency of the compressor. There are common remedies. We are also going to look at all of this. So we are going to look at the first, okay, which is surge. So surge is like a sudden and violent reduction in flow and pressure. And the usual effect is that you see the equipment vibrating, okay, excessively. So surge usually is like a back pressure. That is when instead of the compressed gas to be discharging, it's not discharging. Instead, it is returning to the suction. Are we getting it? So since it's returning to the suction, it means that it will act against the incoming compressed air. So that can cause surge, and surge has very drastic effect on the compressor because it can result to serious vibration of the compressor. So surge, like we said, is like a reverse pressure, okay, that is acting against the normal pressure within the compressor, and in most cases it's as a result of maybe the compressor not discharging properly. So if that happens, you'll see that we'll have a lot of compressed gas in that discharge area that will force itself back into the compressor. So what are some of the remedies? One, we can increase flow, open up the discharge so that we'll have the gas or the compressed gas flowing out of the compressor without much hindrance. So once we increase the flow, that will tend to decrease the back pressure on the incoming compressed air from the suction end. Then we can reduce the discharge pressure, okay, by bleeding. We can bleed the the bleed at the discharge, so that the pressure at the discharge end will reduce, which means that it will have an alternate route to relieve itself. Then we can also employ such control devices, okay, especially in the inlet, trying to reduce the amount of air or amount of gas that we are administering into the inlet, so as to reduce the volume of gas that will be compressed within the compressor. So we can use the inlet guide vane. So that's what you are seeing here. Okay, so this is the control. So we can use the inlet guide vane. As it's opening up, it increases the amount of gas or air that is administered into the compressor unit. Then as it's closing, it reduces the amount of gas that is administered into the compressor unit, and that is what we are seeing here now. Okay, so once you control the opening of this inlet guide vane, you will be controlling the amount of gas that will be administered into it. So when you close it, that will reduce it, and then reduce the amount of gas that is compressed towards the discharge, and that will also reduce the back pressure on the compressor. But if this does not work, you have to open the bleed valve to bleed off the excess pressure to relieve the compressor of the surge. Then, like we said, the other fourth condition, which is stall, is similar to surge, but at a lesser scale or less severe compared to surge. So it is basically the same thing. Okay, so we can remedy this by controlling. The, like what we did earlier. Okay, increasing the amount of gas that is taken off the discharge, relieving by opening up the bleed valve. Okay, then we can also control the inlet guide vane, okay, to adjust the amount of gas that is administered into the compressor. So we can do all of that, reduce the discharge pressure, modify the compressor inlet guide vanes, as we saw earlier, to control the amount of gas that is administered into the compressor. So high temperature at the discharge, that is high temperature here, okay, and we know that once the temperature is excessive, if it is too high, it will reduce the efficiency of the compressor unit, apart from the fact that it can destroy other equipment downstream. Okay, it can reduce the efficiency of the compressor unit. So what are some of the remedies that we can adopt in taking care of this high discharge temperature? Okay, one is to check for fouling or deposit on the impeller, that's one, or on the heat exchangers. Okay, here now we have two heat exchangers, the heat exchangers, then here we also have another heat exchanger. So these are the intercoolers, and this is the aftercooler. Okay, so if there are fouling within these heat exchangers, you see that the rate at which heat is taken off the compressed gas will be reduced, and once that happens, the discharge gas will, that is the what will come out from the discharge end of our compressor unit, you see that it will be of high temperature. So we want to check to see that there are no foulings, so which means that we want to maintain a regular routine of preventive maintenance on our heat exchangers or on the intercooler and the aftercooler. Then the cooling water the temperature at which it is entering. Those are operational parameters. So we want to make sure that it is maintained at what is recommended in our facility. Then the temperature at which the cooling water is coming out will also give us an indication of what is actually happening within the intercooler. So if the delta T is high, that means it is very effective. But that is if the discharge, that is the outlet temperature, okay, that is the temperature of the water on this red line now, which is the outlet, is far higher than the temperature, the inlet temperature of the water, okay, you will see that will mean that the heat exchanger is very effective, is absorbing enough heat from the compressed gas. But if the delta T, the difference in the temperature, is so close, it means that it's not that too effective. So we want to maintain that operational parameter that is optimal, okay, which means that we want to be looking at the inlet and the outlet temperature of the cooling water from each of these, the intercooler and the aftercooler. We want to look at them to ascertain whether they are working properly. And if the delta T is small, that could be an indication that we have a lot of fouling within the inter and the after cooler, and then we can call for maintenance. But for us to be on the safer side, we want to know the delta T that is tolerable for us, okay, so that as it's reducing to a level, we can flag off an alarm. Then it will reduce to a level we know that the intercoolers and aftercoolers, they are due for maintenance. Then we want to inspect the compressor components, okay, so all the components of the compressor, that means we want to maintain a regular preventive maintenance inspection. So we do not want to forego the normal routine of our inspection, the operational routine too, which is the check of the inlet temperature, discharge temperature. And we know that the inlet temperature will affect the discharge temperature into the compressor. That is the compressor of the gas entering the compressor. This is a two-stage compressor. This is one of the centrifugal compressor, okay, and this is the other. So this one compresses the incoming air, sent into the intercooler, and then it comes into the second stage or the second compressor. This compresses and then sent to the aftercooler. Then after cooling, it is sent into the process, okay. So if we have instrumentations telling us the temperature and pressure of the input gases, temperature and pressure of the discharge gases, okay, discharge gas, that will give us an indication of whether everything within the compressor is actually functioning properly. Then we can also carry out other condition monitoring techniques that will help us to have an insight as to what is actually happening within the compressor, okay, like vibration analysis. So we'll take that together with this. So another fourth condition that is inimical to the normal operations of the compressor unit is vibration. So what are the common things that can cause vibration? Unbalance of the rotor, okay, can cause vibration. Okay, in this case now, unbalance of the impeller, the compressor impeller, can also cause these unbalanced forces that will increase the vibration. Then one bearing, okay, at the back of the compressor now, those bearings, the one at the gearbox, okay, front and back, even the one in the motor, all of those, they can increase the vibration of the unit. and then misalignment between the gearbox and the electric motor. The coupling, if it's misaligned, that can increase the vibration, and even between the compressor and the gearbox, if it is not properly aligned, all of those can increase vibration. So what are the remedies? So if we notice that we are having high vibration, we can carry out vibration analysis on the motor, on the gearbox, and on the compressor end. Okay, so that analysis will tell us what is happening. If we are having unbalanced forces, they will show. If it is the impeller, we will also see it on the measurement we took at the compressor end. If the unbalanced forces is on the rotor this way, it will also see it. It is vibration analysis that will assist us in taking care of, or in seeing the problem as it's developing, and then eventually taking care of the problem. So we also want to replace worn bearings once we see that the bearing is the cause of the excessive vibration. So the bearing vibration, we also see them in the bearing frequency range in our vibration spectrum. But if we are looking at journal bearings, okay, that we will see in the sub-harmonics, increased vibration in the sub-harmonic, in harmonics in the vibration spectrum. Then if it is problem with the impeller, okay, we'll see some increased vibration activities around the vane pass frequency of the impeller itself. Okay, so all of those will give us an indication as to the reason why we are having excessive vibration. Misalignment too, as is trying to overcome the misalignment force, either at the coupling between the gearbox and the electric motor, or if it is direct coupled, or between the compressor and the gearbox. Okay, if there are misalignment, all of these misalignment forces will contribute to the increased vibration, and all of this we also see during the vibration analysis. So seal leakage, we know that can drastically reduce the efficiency of the compressors. So once the seal is leaking, that means that the compressed gas will be losing pressure, because we'll be releasing compressed gas into the atmosphere, and depends on the kind of gas. If the gas is corrosive and it is exposed, the other components of the compressor unit like the bearing and what have you is exposed to the discharge gas from the leaking seal, that can affect the bearing or other components of the compressor. So we want to remedy the situation once we observe as such. So what are some of the things that we can do to take care of seal leakage? Of course, once we notice it, we want to call for maintenance to replace that seal. Okay, replace the seal so that the efficiency of our unit will be restored. Then during installation too, we want to take care to follow the standard operating procedures in installing that seal, as recommended by manufacturer and as modified in our facilities from experience on that compressor. So we want to ensure that we install that seal properly, so that there won't be any maintenance induced problem on that seal end. Okay, then we want to operate the compressor properly. During normal operation, we want to follow standard operating procedures in operating the compressor as recommended by our facility. Okay, we want to follow it diligently so that we can safely and reliably operate the compressor without inducing issues on the compressors. So still on faults and remedies, bearing problems. Okay, remember the overheating that we talked about the other time can actually heat up the bearing and damage the bearing. Okay, then misalignment between the driver, the gearbox, and even the compressor itself can lead to bearing failure. So, and for us to observe this, bearing, once it starts failing, vibration will definitely increase. So we can also carry out vibration measurement and analysis, okay, to tell us when the bearing is failing. So what are the remedies? We want to carry out vibration analysis so that before it will get to a stage that will affect the operations of the compressor, we would have seen it and taken the necessary step to remedy the situation. Then lubrication too. If this rotating component, the bearing, is starved of lubrication, which is meant to reduce the friction at this component, of course that will increase the wear and tear, okay, that will eventually cause its failure. So we want to maintain proper lubrication routine on these components, the bearings, okay, so that will reduce the bearing failure. Then the temperature too of the bearing, when the bearing is malfunctioning, you see that the bearing temperature will be increasing. If the grease is not enough, the bearing temperature will also increase. If we have excessive grease even, that can also increase the bearing temperature. So the bearing temperature is an important parameter in the operation of the compressor that we should always be looking at or monitoring, okay, so that if it is deviating from what is normal, we know that something is developing. It's even a simple means of looking at the health of the compressor, so that if it is increasing, we can bring in other technologies to help us to look at the bearing to ascertain what is actually happening within the bearing, okay. Then once it is too excessive, we can inspect for damage. Maybe our analysis took us to the bearing, and maybe the bearing is not even the cause. The problem is induced by some other component and is only reflecting on the bearing. But when we take the bearing out, we will see that the bearing is okay. That will help us to want to determine the true cause of the increased vibration of bearing failure. So the last that we'll be looking at is the erosion of the impeller and the diffuser. Okay, so the as the gas is accelerated, it's of high speed. It's actually impinging on this component, and especially if the gas is containing some particles, that will increase the erosion, that is the wear of the surfaces of the impeller and the diffuser. Okay, so what are the remedies to this? One, we want to use impellers that are erosion resistant. So which means that we want to know our process. I want to know the condition to which the compressor will be subjected to. So, and then that includes the nature of the gas that we are compressing. So if we know that it is of a material, is composed of things that will cause the erosion on either the impeller or the diffuser, then we want to select impeller and diffuser that could resist those the erosion of those particles or those contents. Okay, so we want to use erosion resistant materials, select impellers that can resist those erosion. Then we can reduce the amount of particles that is administered into the compressor by using the inlet filtration system, an effective one. Okay. Then we also want to operate the compressor optimally. Follow standard operating procedures to see that the compressors does not run outside what it is designed for. So if we use it like that, we'll see that the compressor will last for us.